This is a tutorial on writing a visual workflow for converting a CAD model into a blocky representation where the user controls the size of the blocks. This program was created with PUPPICAD, a powerful, free, computational design development environment. You can download PUPPICAD from puppicad.xyz. Let us first load a 3D model from a file. Let us connect the output of the CAD file node to the input of the 3D model access node to preview the original model in the CAD window. We will get point contours of the CAD model as it intersects several planes. In order to make this program work for any CAD model we load, we will base our plane generation on the extracted dimensions of the model bounding box. We will pick the y-axis to create planes normal to. We displace the first and last plane positions slightly inner of the extreme bounding box y coordinates, in order to ensure good intersection of the cutting planes with the model. We use a for loop node to generate several y coordinates for the cutting planes. The loop step size will be a user input and will also be the value of every side of each block. The cutting plane normal is a vector parallel to the y-axis. The plane node will have to process in list mode. Since the normal vector does not change, we will set the plane normal input to automatic list processing. The plane origin input will be connected to a list of points. The only point coordinate that changes is the y. The get 3D model contours node will also process in list mode. It will take as inputs the list of cutting planes and the CAD model from file, the latter input processing in auto list mode. A list of contour points is generated for each child of the 3D model supplied, therefore when the get contours node processes in list mode, the result is a three-dimensional array-type structure of points. We assume the 3D model has no children, so we will take only the first column from the grid-like structure containing contours, where each contour is actually a list of points. Let us visualize the extracted points. We will reduce the dimension of the output of the get grid column node to a one-dimensional list of points. We will convert the point 3D variables to renderable point objects and add them to the 3D model access node input. You can see that the contour points are not distributed uniformly. We convert each contour into a polyline object so that we can manipulate the point resolution. We refactor the polylines based on the block side entered by the user. We now should have a fairly even point distribution on every contour, with the distance between points close to the block side specified by the user. We convert each polyline into a list of points. As you can see, the points are evenly spaced now. We will now add a box at each point. The box diagonal will be a vector with each component equal to the block side. We now have a very blocky version of the CAD model. Let us increase the resolution by decreasing the block side. Let us decrease the block side further. Thank you for watching this tutorial video. You can download PUPPICAD for free at puppicad.xyz.